Hello, this is 1C, and then we're going to talk about science, true science versus science fiction, as well as some of my favorite movies. And science fiction is just weird. Science fiction movies are fun to go see because they actually have some weird, really cool ideas. They do things that are not possible, but they do things to sell tickets to make money, to actually raise consciousness in terms of people's ability to pull in information. Favorite movies, we'll talk about some of those actually being science fiction. Most of them actually are. Some astronomy stuff may be weird, but it's actually true. Things like black holes. And black holes are weird because if you take a look at the laws of physics, they actually can explain some of what's there, but not everything. We have a couple of different principles we'll talk about later on that actually talk about neutron stars turning into black holes and the singularity actually coming about. You can also watch PBS's How to Build a Black Hole to be amazed and confused in terms of black holes. We also have radiation from the beginning of the universe, 3.7 billion years ago when the Big Bang actually happened. It was a big explosion, and if you have ears big enough, the explosion is still there. It's sort of weird, but if you kind of think about people talking, if you had bigger and bigger ears, you could hear it from farther and farther and farther away, and even from a distance of 13.7 billion light years. And then we'll also talk about true science in movies too. One actually just came about not too long ago. So, spinning black hole. And the first thing I'd like to talk about is I was told that you can actually embed a YouTube video inside of a PowerPoint, and I have tried. I could get it to work in school, but I can't get it to work at home. I'm using Office 10. If you could definitely figure out how to do that, I would appreciate it. I've basically made a Apple type device background, and I'm supposed to be able to play these YouTube videos right here, but as you can see, if I click it, I can't. So I have the YouTube video down here, and I do want to show these to you, and I may get into trouble with actually using copyrighted YouTube video in my YouTube video, but what the heck. And this is a spinning black hole. It's got energy going up in gamma rays. It has mass spinning in. This is the singularity. The black hole is in here somewhere. This is as far as we can actually see. And then we'll look at non-spinning versus spinning black holes in terms of energy level. And if you take a look, they all have energy of about 6.55, maybe 5.6. And you can see it's about the same location, maybe a little bit lower in terms of the spinning black hole, but they actually have this same sort of a curve, even though we get more energy in a non-spinning than we do in terms of a spinning. I wish they actually gave us this other y-axis, and we can figure out why these things are going up rather than just moving off on the horizon. But here we go. Spinning black hole, or excuse me, a non-spinning black hole, and you can see the singularity is not moving. We still get a spin inward, and we still get this beam of gamma rays, high energy rays, X-rays going out. And here is a spinning black hole. Same sort of thing. Can't tell if we're looking from the bottom up or that looks like more like the top down. And there's the energy curve. And you can see it zigs and zags. And then here are the two. Non-spinning, spinning. Energy levels look like they're similar, maybe a little higher in the spinning black hole, but I don't know why the spinning and the non-spinning black hole, the energies are higher, and I don't know why it's not as high, because they don't give me what the y-axis actually is. Okay, radiation from the Big Bang. This is the Wilkinson microwave anisotropy probe. It's called the WYMAP. And if you take a look, we have some high concentration microwave sources and low concentration microwave sources. And we can see that it's not actually the same all the way around. It's not homogeneous. It's not trophic, where we actually have a concentration being the same all over. It actually looks like it's fighting. So we have a large concentration of matter here. And again, this is the known universe as far out as we can see. Here's another look. This is the COBE background radiation, COBE Cosmic Background Explorer, and we have high density areas and low density areas as well. And this is evidence of the Big Bang. This is the remnants of the Big Bang. And then movies, science fiction movies. This one actually came about, I want to say, in the mid 70s when I was actually graduating from high school. And of course, this is Lord of the Rings. This is 4, 5, and 6, the best ones. And Feeling Safe. And then we have Alien movie, which I absolutely love. Totally cool creature. Actually goes inside and does all kinds of damage to people. I don't think I can show either one. Maybe Lord of the Rings. Maybe, did I say Lord of the Rings for this one? This is Star Wars. I don't know. I can't believe I said Lord of the Rings. I like those too, but Star Wars. And these two movies are actually not based on true science. They're there to sell tickets. And then there's the movie Martian, which actually did use true science, where we had 6 astronauts moving up in a spacecraft to go on Mars. Actually accidentally left one person, had to go out and plant potatoes, had to actually try to get to a new area using the rover, and it talked about science and solar panels and actually working things. So the science of potatoes, the science of rover, and actually the science of the planet and the study were true. Sold lots of tickets as well. But that's a harder process to do than it is to actually do computer. And I'm not saying that this is really Mars, because we have not been there. We've had unmanned spacecraft, which we'll talk about later on, but we have not been there with manned spacecraft. Be totally cool when we do. And you can see there's our stop. So thank you for stopping by, and that is the end of Unit 1. Bye.